All right, guys. So we're back. So as I was saying that for ratios, our shares would have no units. All right. So because we are sharing in ratios, you'll find that units will cancel out. Just in a similar way, when we are canceling, the units will cancel out, and so there will be no units when we are writing ratios. All right, so you notice that for the share, we don't really have any units beside them. All right, now ratio is a very important topic because ratios are used in many ways. It is used for businesses. If you're operating a business with someone else who you consider your partner, you may want to take into account the idea of ratio. Now, if you're going to start a business with your partner, then obviously both of you will have some amount of contribution to the business. Now, sometimes if you're looking in terms of capital, you may have one person putting more money than the other person, right? And so if you have one person putting in more money in terms of investment, then what is really expected, or what would be fair, is that the person who puts in more money, you would expect that that person would get more profits. So one of the things that will happen when the persons do their investment, they can also share the profits in the same ratio as the capital. So based on how much money you put, how much your partner puts, you can share the profit in that ratio. And that would be a pretty fair share, because you can't expect to get more for smaller or for lesser capital when in fact the other person would have put more than you. Right? So that's one of the ways that you can have a fair share for ratio in business. Now, you may have ratio using this in a sense where you may have persons investing in companies and they buy what they call shares, and the shares that they buy is really what you would consider to be an investment. So in other words, your share is like putting in money into the business or into a company. Your money that is put into the business when you buy your shares is a part of investment, and in other words, you are contributing to the capital of the company. So that money that you put in, they will calculate your profit based on what ratio you would have invested in a company. All right, so that's the idea behind ratio. So with that said, we are going to be looking at some questions. Now, this first example says that you have to express 20 cents to $4 in its simplest form. All right, so the ratio of 20 cents to $4 in its simplest form. How would you go about doing this question, Ms. Travia? Ms. Travia, are you there? Hearing me?
Yes, sir.
Any idea how you would approach this question?
You would have 4 to 20.
Okay. Anybody else who would like to give some input to this question? What about you, Ms. Taylor? Ms. Taylor, are you hearing me? Ms. Taylor, are you there? All right, let me ask someone else. Mr. Paisley, how would you approach this question?
20 to 4, sir.
All right, 20 to 4. All right, anybody else have any?
And reduce it to the simplest one.
Okay, anybody else have any other idea apart from what Mr. Paisley has? Let me see your hand.
Sir,
This way, some go ahead.
would it be that you have to change the $4 into cents first?
Well, one would only consider that you would want to work with the same units when you're doing the ratio. All right, so in other words, if you're sharing in terms of dollars and cents, what you have is a confusion. Because if you say 20 cents to $4, you would obviously have to convert either the $4 into cents or the 20 cents into dollars in order for you to get the share correctly. You understand that, Mr. Paisley?
Yes, sir.
Right, so the first thing you want to do then is to convert your units so that all the shares are having the same units. So in this case, if we convert $4 to cents, how many cents you would get from $4?
400.
All right, so we know that $4 is equal to 400 cents. And so we first have to do that conversion before we actually simplify the ratio. So what we know then, 20 cents, 20 cents to $4 then. All right, let me just use the colon. So 20 cents to $4. That will become 20 cents to 400 cents. And once you now have it in this form where both of them have the same units, then what will happen is that the units will cancel out. And so the ratio won't have any units, all right? Now, so if you're writing this in its simplest form, it means that you want to reduce it in a form where the ratios have their smallest numbers. All right, so anybody would like to do the calculation for this and tell me what the ratio would reduce to?
Yes, sir.
Go ahead.
You have to cancel out the 0 from the 20 and the 400.
All right, so you can cancel out zeros with zeros.
Yes, sir.
And then now you'd have 2 to 40.
And then say 2, and then say 2 into itself 1 and 2 into 40.
And 2 into 40 goes.
20 times, sir.
All right, so it means that in its simplest form, this ratio would reduce to 1 to 20. Anybody agree? Let me see the hands of those who would have done the same thing. Right. All right, very good. So that is what we have to do when we are reducing or expressing ratio in its simplest form. You simply write the ratio just like fraction, you find the highest common factor and divide it down, cancel down to its lowest form. All right, so as we see, $4 would be 4 times 100 cents is 4 cents. So you would have that. The ratio would be now 1 to 20. All right. Now, here is another question. I'm going to give you a chance to see if you can simplify this ratio based on what you have just seen. See whether or not you'll be able to simplify this ratio in its simplest form. So I'll just give you about 2 minutes to try it, and then I'll walk you through it. Go ahead now, students. All right, so I saw a response in the chat from Miss, let me see. That would be Miss Moisha, Miss Taylor. Do you have an answer to this question? Miss Taylor, is it that your mic is not working? Because I'm not getting a response from you. All right, is there anyone who actually finished with the simplifying of this? Okay, all right, noted, Miss Taylor. All right, so students, I would like for you to use up your mic so that others can benefit from the discussion. All right. Whenever you are through simplifying this ratio, raise your hand, and then I'll come and you will walk through the question. Okay, so obviously I am not getting anything from your end, Miss Moisha. So if you're talking, you may want to check to see if your mic is on mute while you're talking. So you have to unmute your mic so that we can hear you. If not, then it might be some other problem to do with the internet. All right, let me find out from anybody. Miss Green, are you there?
Yes, sir.
All right. Were you able to work this question?
No, sir.
Okay. All right. Is there anybody who would like to walk me through what they have? What you have, Miss Green? You don't have anything at all?
Sir, oh, sir, the fraction part, sir, is kind of confusing, sir.
Or the
The,
fraction part is
the,
confusing you? All right.
yes, sir.
Anybody else? Miss Wason?
Sir, I was thinking of taking the same procedure, sir, where we convert the 4 into fraction. So I was looking at it to say that a quarter into 4, that would have been like 4/16. That's what I came up with. So I'm not sure.
So your answer is 4/16?
No, sir. I would have got 4/16 to the 1/4, and then I would have canceled out from there.
Oh, okay. All right. And what all right. So do whatever you're thinking about and see what you get and let me know.
Sir, so we have the 4/16 and then the 1/4, sir. I
Mhm.
just use the 4 in the denominator to cancel the 4 in the numerator of the other fraction.
4/16,
Yes, sir.
and you have the 1/4,
Yes, sir.
and then you cancel out.
The 4 in the denominator and the 4 in the numerator, sir.
All right. What is happening here is that you would have done something to one ratio that you didn't do to the other one. So in actual fact, you have divided the 4 by 16, not divide the quarter by 16. You follow what I'm saying?
Okay.
Is that you would have had some imbalance there. So, you know, like a fraction, anything you do with the numerator, you also want to do it with the denominator. So anything you do with one share, you also need to do the same thing to the other share. So it's a good attempt, but it wouldn't work out in that sense.
Okay, sir.
All right, so just to give a little clarity on this question, since nobody is able to find a way, now, Ms. Quevedo, go ahead.
Sir, I don't my answers right, but I got 16 to 1.
All right, so how you get the 16 to 1?
I convert the
Walk me through the steps.
alright, so I convert the 1/4 to decimal. So it's gonna be 0.25.
Oh, so you convert this to decimal, and then now you try to work in terms of the ratio of the whole number and the decimal.
Yes, sir.
All right. It could be an approach, probably not the best approach, but could be. All right, so let us look at it from a simpler perspective. Now, one of the things about ratio, because they're from the fraction family, it also means that we can oftentimes express two shares in the same way how we express a fraction. All right. So if we have the share of 4/4, now if we are to express this ratio as a fraction, we would write we would write the number to the left of the polar, which is the 4. We'd write that as the numerator, and the number to the right of the colon, we write that as the denominator. So if we are expressing this ratio as a fraction, our numerator would be 4, and our denominator would be a quarter. So we are here now treating this ratio in the same way how we treat a fraction. All right, now, so if this is a fraction, then what we know is that for fractions, their numerator is divided by the denominator. So really, this would be 4 divided by a quarter. So if we have 4 divided by a quarter, then remember now, we're applying the same rules when we are dealing with fractions. So if you're dividing a number by a fraction, what is the rule?
Flip the second fraction, sir.
All right, so what you're supposed to do, you're supposed to change your division sign to multiplication, and then you invert the divisor or flip the divisor. So you change the division sign to multiplication, then you invert the divisor. The divisor we already know would be the number that comes after the division sign. So in other words, we would flip the 1 over 4, which is a quarter, and now it becomes 4 over 1. All right? And so, treating it like a fraction, you would multiply the numerators together. So you get 4 times 4, 16 above. And then 1 times 1 give you 1 below. And now this fraction, we now can express it back as ratios. So we are just putting the numerator as the first number of the ratio, or the first share. And we then put back the second number as the denominator of the fraction. We then write it as the second number in the ratio. And so the ratio, when you simplify the ratio of 4 to a quarter, it is simplified to 16 to 1. Is that clear, guys?
Yes, sir. But sir,
Yes.
you see, even though you say the approach that I took
Right.
would not be that way, but I actually got the same
It
answer.
would have led you to the same answer, but what?
That this would have been the correct way for the layout.
Yeah. Why?
Okay, sir.
Why? I would have brought that to your attention because oftentimes students will try something and they get the correct answer, but you don't have the correct procedure.
Yes, sir.
In that sense, even though you get the correct answer, you only get marked for the answer, but you wouldn't get marked for the procedure.
Okay, sir.
All right. All right, so just as before, we give you this layout and we get the ratio of 16 to 1. Now here we have a worded problem now in ratio. It says that 2 lengths are in the ratio of 8 to 5. If the first length is 120 meters, what is the second length? Now, just giving you a little chance to see if you could apply some reasoning to it before I actually work it for you. So just take about 2 minutes, think about the problem and see if you could come up with an answer for the second length. Go ahead, students. All right, anybody came up with any solution? Mr. Campbell, any solution to the question?
Not at the moment, sir. No, sir.
Okay. What about you, Mr. Giovanni? Any solution?
Almost finished, sir.
Almost finished. All right. Anybody else? Miss Scott?
No, sir.
No.
Just finished.
All right, Miss. Who was that? Mr. Giovanni?
Yes, sir.
That all right. Go ahead. Walk me through what you got.
The first step, I did put 8/5.
All right. So you put 8/5.
Equal 120.
Equal to 120. Let me see if I can write that a little better. Says 120. Yes, go ahead.
And then I put 5 times 120/8.
Okay, so that's below.
Yeah, that's below.
Could you help me to set that out? So you say you put times
But 5, the 5
yeah,
times the 120.
and you divide that by
8, sir.
and what you get?
So I may multiply the 5 times the 120 and get 600. Then the 8 into 600, that'll be 75.
All right. Anybody agrees with Mr. Giovanni? Anybody? Just 75, Mr. Giovanni?
Yes, sir.
Okay. All right. Is there anybody else who want to add to what Mr. Giovanni has done? Miss Waysome, anything to add?
No, sir.
Miss Travia?
No, sir.
Anybody agrees with his answer, with Mr. Giovanni answer? Let me see the answer, those who agrees with the answer that Mr. Giovanni. All right, so that tells me that nobody sure is how Mr. Giovanni got his answer. All right, now, actually the answer is correct. However, there's there's a few things wrong with what is happening here. All right, but good reasoning, Mr. Giovanni. So a few things are missing here. So one, your length should take back the units, so your answer should have meters. All right, Mr. Giovanni? So that's one.
Yes, sir.
And what you set out here does not give any real logical connection. Even though you have this set out, you really don't know how the 8/5. This is not logical because 8/5 could not equal to 120. You follow what I'm saying?
Yes, sir.
Right. Now, your calculation here leads you to the answer. But this part would be wrong. You follow?
Yes, sir.
But I think you have the right idea. So you need now to just pay attention to the little details that I'm going to explain now. All right. So, all right. So what it should have been then in terms of what we would have learned. All right. So let me clear what we have here and then go from scratch with the question. So actually, if we are looking at two lengths, and one of the things that students sometimes forget to do is that they forget to analyze the question based on the information that they're given. All right, so here you have a length that is shared in two parts. You have the length are shared in the ratio of 5:8. So what would you expect in terms of the share? Which of the portion would be bigger?
8, sir.
The 8. So it means if you're sharing this length into two parts and one part is bigger, you have to cut the length so that it reflects one part bigger than the other. So let's say you put the mark there. So in terms of the share, we could say let this share be in the same ratio of 8:5. All right, y'all agree?
Yes, sir.
All right, so let me fix that. So this is the 8 and this is the 5. And so this share is in the ratio of 8:5. Now here they tell you that you have the first length to be 120. And they want you to tell them what is the second length. So you know one of the length, but you don't know the other one. So the first length would be representing which ratio?
8, sir.
The 8, because the first length has to do with the first ratio. So it means that the length that is 8 would have the length that has the ratio of 8 would actually have the length of 120. All right, now it means then the length that we don't know would be the length for the 5. So we could call that x. What we know though is that the lengths are in the ratio of 8:5. So it means that the 120 to x is the same as the ratio of 8:5. Now, as what Mr. Giovanni would have done, he would have written the ratio in a fractional form, because it is quite okay to express a ratio in the form of a fraction. So you could have 8/5 and then we could equate that to the ratio of the actual length. So the actual length would be 120 to x. What we don't know is the x. So that's what we're trying to find. We're trying to find what the x is. So here we now have an equation that we can work with. All we need to do is to solve the equation for x. All right. So in solving this equation for x, we generally need to get rid of the denominators. And to get rid of the denominators, when you have two fractions equal, you simply carry out a method that we call cross multiply. Take the denominator of the left side and times it by the numerator. Or take the denominator of the right, times it by the numerator of the left. And also we take the 5, the denominator 5 at the left, times it by the numerator 120 on the right. So once we do that, we would get rid of the denominator. So what we would get is a times x is equal to 5 times 120. Now, when we're solving for an unknown, in this case, we want to find the unknown x. What we generally do is to leave the x by itself on one side of the equation. So if you have a number beside the x, to get rid of that number, you would divide that side by the same number. So you divide this side by 8. Now, since we are dealing with an equation, whatever you have done with one side of the equation, you need to do it with the other side. So you divide the left side of the equation by 8, and you also need to divide the right side by 8. So this will cancel, and now you will see where x then will be equal to 5 times 120 divided by 8, and that will lead you to the answer that Mr. Giovanni has gotten. So that would work out to be 75